This problem, we're given an exponential equation, and we are to solve it and write our answer in both exact form and as a decimal rounded to the nearest hundredth. So I took the liberty of switching the order here. I found that some students, not all, like it better to having the number on the right-hand side as opposed to left. Either way, it works. Since the 95 is being multiplied, I think the first thing that I would do is divide both sides by the 95. It simplifies out to be the number 1 over here. 95 divided by 95 is 1, leaving me with just 1.15 raised to the x. In fact, there's no need for parentheses anymore. So I'm just going to have 1.15 to the x. The reason for the parentheses here was to indicate the multiplication and to indicate that the 95 wasn't part of the base for the x. Now that the 95 is gone, I do not need the parentheses. Now remember that I'm supposed to leave my answer in exact form in the first case, so I'm not going to give a decimal approximation for this fraction here. What I'm going to do is just change this from what's called exponential form to log form, and I'm not going to give too many details on that besides just that to change to log form, the base and the exponent go in the following positions. So the base here is 1.15 and the exponent is x. So you need to write the base down here as a subscript, 1.15, and the exponent over here, x. In fact, I found that myself and students alike typically are better going this way from log form to exponential form. So what I do is I almost kind of do that in my head, that I know that in log form this gets raised to this power to give this result, right? 1.15 gets raised to the x to give me this ugly fraction here. So the ugly fraction there would go in parentheses. Actually, you don't need parentheses. I just prefer parentheses there. And notice I'm writing it bigger than the 1.15 because it's not meant to be a subscript. So you are to look at this as that the log base 1.15 is just the name of a function. This is exactly like if I said f of something. So f of input. So this is the name of the function, and this ugly fraction happens to be its input. So we're inputting this number into the log function. Please don't think of this as there's multiplication involved here. There's no place in here that has anything to do with multiplication. So this is the exact form. You can think of the advantage of an exact form, not that you need it often in many applications, but the advantage of an exact form is it has infinitely many decimal place accuracy. You need only have a computer that can generate as many digits as you want out of that. Now to type this in a calculator, because I don't have a button on my calculator that does base 1.15. In fact, let me switch to the calculator real quick. I have a log button on my screen, but notice there's no base written. We are to assume that this button gives me a log base 10. Well, I don't have log base 10, I have log base 1.15. So I need to change it. I need to change the base, and that's why I'm going to use what's called the change of base formula. That I can change this from a base 1.15 problem to a base 10 problem by simply taking the log of this ugly fraction, 190 over 95, and dividing it by the log of 1.15. So I need to type this in my calculator again because I didn't write the base. Make no mistake, I converted this from a base 1.15 problem to a base 10 problem. So even though I'm including this number, it's no longer occurring as a base. The base here is 10. So to get a decimal approximation of this, I'm going to go to my calculator and hit log, and it gave me a left parenthesis for free. Well, 190 divided by 95, and I'm going to close that parenthesis. That's my numerator, and divide by my denominator of log of 1.15. Put a right parenthesis to cap that one off. Press enter. Now remember, I'm supposed to round to the nearest thousandths place. The thousandths place is the third decimal, right? This is the tenths. This is the hundredths, and this is the thousandths. Because that's a 4 there, which is a number smaller than 5, I won't round this digit up. So 4.959 is what I get out of that. I'm going to put a squiggly equals because that's just an approximation. So you could check it. You could go back to your original equation, which was here, and replace x with that number and check to see if it works. So if you have the patience, I'm going to do a little check over here. I'm claiming that if you raise that number to the 4.95 power, that you should get approximately 190. So if you rounded this, you wouldn't get 190. A neat feature on the calculator is you can actually do this sort of without rounding. Technically you are, it gets a little complicated, but it works. Watch what happens if I was, instead of rounding this number, if I was to type 95 and then multiply by 1.15 and then right parenthesis, if I was to raise to not 4.959, but I used the previous answer feature, just above the negative key in your calculator it says A and S. So if I pressed second negative, puts an A and S here, what it's going to do is raise this 1.15 to the previous answer. And even though the calculator rounds this in here, it turns out doing so gives you exactly 190 and allows me to check it. So had you not done it that way, had you rounded to the nearest thousandths place, you could still check your answer for reasonability. I call it a reasonability check. You just wouldn't expect to get exactly 190. You'd get something close, like 189.987, for example.